Hi guys, once more welcome back to our mathematics tutorial, and my name is Peter C. Dogba Jr., your math tutor. I'm also an instructor of mathematics at the University of Liberia. In today's lesson, we want to continue with finding the nth derivative. So if you have not watched the previous video, I urge that you go back and watch the previous video on question number 1 up to 7, so that at least you have an understanding of how we can find the nth derivative. Now I want to find the nth derivative of these trigonometric functions. Now, the reason is because these trigonometric functions always repeat. Their derivatives always repeat. After a kind of pattern, they always repeat. So after you find certain number of derivatives of these trig functions, you understand that you go back to, it's almost like you are going around a cycle. So based upon that, we want to find a formula, or we want to find a technique that we can easily use to find whatever derivative we want to find of these trig functions. That is, we want to find the 100th derivative, the 100,000 derivative, the 50,000 derivative. Some instructors may ask you to find the 1 million derivative of this function. So I don't know how useful it will be to you, but some instructor may just ask you to do that. And if you say, I want to find this thing manually, you take a copybook, prime, y prime, y prime, prime, y prime, 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 prime. You cannot, you're going to consume a lot of time. In fact, you might find out 1 million derivative for over a year or something. So based upon the repeating technique of these trig functions, we want to now derive a technique that you will use. So if they ask you to find the 100,000 derivative, you already know what to do. So let's get started. So question number 8, we say y equals sine of x. So to find the nth derivative of y is equal to sine of x, maybe you ask to find the 40th derivative of y is equal to sine of x. Now, I want to find few derivatives to observe the pattern of the derivative of sine of x. So the first derivative of sine of x, we told you, is cos of x times the derivative of the angle. The derivative of this angle sine of x is just equals to 1. So we are not really bothered by the angle any longer, since the coefficient now is 1. So we just avoid that. If the coefficient is greater than 1 or even less than 1, it could be a negative, whatever the case might be. When it is negative, you can rewrite it. When it is greater than 1, we can apply the methods we're going to apply in these problems to approach that particular problem. But since now the coefficient is 1, we don't bother about finding the derivative of x any longer. So the derivative of sine of x is just cos of x. The second derivative, the derivative of cos of x is negative sine of x, right? So you see, it just coming, going, coming, going. So the third derivative of this sine of x, we know that is cos of x. And then the fourth derivative of this cos of x is negative cos of x. But negative times negative is positive. So the fourth derivative is sine of x. So what's the technique? The technique here is that after every fourth derivative of sine of x, we go back to the original function. So what if you were asked to find, before we find the 40th derivative, what if you were asked to find the 8th derivative? So to find the 8th derivative, if you divide this 8 by 4, you have what? You have 2. So it means we are going to go around this cycle twice. That is, we differentiate this thing the first time, we reach to 4, we got sine of x. If we find another 4 derivative, we come back to the same sine of x. So as long 4 can evenly divide that number, the answer is just sine of x. That's the first technique. As long 4 can easily divide that number, the answer is just sine of x. Technique number 1. The next technique, so for this one, the if derivative, if derivative of this particular sine of x is just equals to sine of x. The 40th derivative, that is the 40th derivative, is just equals to sine of x. Because this 40 divided by 4 is 10. So it's like going around the cycle 10 different times. It's just, what do we want to find? We don't want to find the 40th derivative, the 8th derivative. No, we want to find, for instance, let's take for instance, we want to find the 6th derivative. So to find the 6th derivative, if we divide this 6 by 4, for instance, we want to get 1 with a remainder of 2. So this means we will like go around the cycle for the first time, like find the first, second, third, fourth derivative, right? We go back to sine, and then we are left with 2 more derivatives to arrive at this 6th derivative. So because the fact that the first one that came out of this 6 resulted back to the original function, which is sine of x, we just need to differentiate that sine of x 2 times. Instead of differentiating the sine of x 6 times, differentiate sine of x 2 times because the remainder is just 2. So we're going to differentiate sine of x. So the 6th derivative of this one would just be the 2nd derivative of sine of x, which is now minus sine of x. Whatever we want to find, for instance, we want to find the 29th derivative. We want to find the 29th derivative. Now, we know that if we divide this 29 by 4, 4 goes into 29, goes there 7 times, right? 7 times 4 is 28. So it means we are going to move around this cycle. That is, like for instance, there's a cycle. Let's assume there's a cycle. And then we start from right there. The function is sine of x. Right? We move right here. 1, the first derivative, y prime. Second derivative, y prime prime. The third derivative, y prime prime prime. And then there's the 4th derivative. So the first derivative is minus, let's say it's positive cos of x. The second derivative is minus sine of x. The third derivative is minus cos of x. And then the 4th derivative now goes back to the same function. So if we want to find the 28th derivative, for instance, or the 29th derivative, it means we'll first have to go around this cycle, let's say 7 times. Move the first time, we'll find the first derivative, second, third, 4th, 5th, 6th, 7th, 8th, 9th, 10th. We go around this 7 times, right? And we will still arrive back to this original function the 7th time. Now what will we be left with? We'll be left with the remainder. When 4 goes into 29, the remainder is just 1. The remainder is just 1. So it means we need to differentiate this sine of x 1 times. That's all. So the first derivative will just be cos of x. Thus, the 29th derivative of sine of x is just equal to cos of x. See that? Because we already know that the 28th derivative of sine of x is equal to sine of x. So to leave from 28 now and come to 29, just differentiate sine of x 1 time. Okay. Let's move to cos of x. We want to use the same cycle. So for cos of x, if we find the first derivative of cos of x, gives us minus sine of x. That is the first derivative. Now is equals to minus sine of x. And this is cos of x. The second derivative, we differentiate this. The derivative of sine of x is cos. So times this negative, so it's negative cos of x. So this now will give us negative cos of x. And then the third derivative, the derivative of cos of x is negative sine of x. So negative times this negative is positive sine of x. So this one now will give us sine of x. And then the fourth derivative of sine of x now will give us cos of x. So we go back now to cos of x. So you see, for every four times, for every fourth derivative, we go back to the original function cos of x. So if, for instance, you want to find the fifth derivative, the only thing you need to do is to just divide this 5 by 4. So it's 1 remainder 1. So it means you will already extract the first 4 derivatives from there to arrive back at the original function. And then you differentiate our original function one time. So the fifth derivative now would just be equals to minus sine of x. Okay, so you can do that for whatever derivative you want to find. So let's now look at question number 10 and question number 11. So question 10 says cos of 5x. We want to find the nth derivative of cos of 5x. Or for instance, we want to determine what is the 100 derivative of cos of 5x. So to find the 100 derivative of cos of 5x, we need to first determine what is the pattern. What's the pattern of cos of 5x, the derivatives of cos of 5x? So the derivative of cos of 5x is just minus sine of 5x. So now if we differentiate the angle, the derivative of 5x is just equals to 5. So we bring this 5 back here. So it's minus 5. We don't multiply this 5 by this angle. This is the angle of the trig function. So now we find the second derivative. So y prime prime is equals. Let's get a new mic. So y prime prime now is equals minus 5. The derivative of sine of x is cos of x. Cos of this angle now, 5x. Times the derivative of this angle, which is also 5. So this 5, we can bring this 5 back here. So we continue. The third derivative, 1, 2, 3. This is minus 5. The derivative of cos is negative sine of that angle. So negative times this negative will give us positive. So it's 5 times 5. Times, when we differentiate this angle, also we get 5. So we can say 5 sine of 5x. And then the fourth derivative will just give us the derivative of this sine now is cos. So we're going back to cos. And when we differentiate the angle, we're going to get 5. So it's like 5 times 5 times 5. And then we bring the other 5 back here. So this gives us cos of 5x. So we understand that it's the first cycle. So it starts with the first derivative, the second derivative, the third derivative, and the fourth derivative. So the fourth derivative now takes us to the function. But what is attached to this fourth derivative? So this fourth derivative has 5 times 5 times 5 times 5 times 5. That is raised to the fourth power cos of 5x. So it means whatever coefficient that is attached to this angle of the cos function, it becomes the coefficient, the base of the coefficient of cos. So if this is 5, here you will have 5. If this is 10, here we'll have 10. If this is 20, this will be 20. Now, the power of this expression depends on the derivative. So if it is the fourth derivative, it will be 4. The third derivative, it will be 3. The second will be 2. The first will be 1. So now to find the 100th derivative, we're going to have, the first thing we're going to have, y raised to the power 100 equals, now this is 5, so it's 5 now raised to the power 100 cos of, now let's determine what is here. The 100th derivative. So if 100 is being divided by 4, 100 divided by 4, 4 into 10, it goes there 2 times. 2 times 4, or 2 times 4 is 8, remainder 2. 4 into 20 goes there 5 times. So 4 divided by 100 is 25 times. So it means 4 is going to divide 100 evenly. There will be no remainder. It is the remainder that you're going to use to find the derivative of that cos function. So if this had a remainder of 2, you would have differentiated this cos of 5x 2 times. If this had a remainder of 3, you would have differentiated this 3 times. If this had a remainder of 1, you would have differentiated this 1 time. Mind you, another secret is that you cannot differentiate this expression more than 4 times, or say more than 3 times. You cannot. You cannot differentiate this more than 3 times, because when it reaches 4, it means you already know that it is the original function. So because this is an even function, that is, when it is being divided by this 4, it gives us remainder 0. So it means it will be cos of 5x. So at this 4, is it positive or negative? It is positive, so it's going to be cos of 5x. So the 100th derivative is 5 raised to the power 100 cos of 5x. That's a 100th derivative. So now you can find cos of, let's say, 5 raised to the power 100. Now let's solve the last problem. So what I want to find, sine of 2x. Sine of 2x. And we also want to find, for instance, the 98th derivative of sine of 2x. How can we find the 98th derivative of sine of 2x? So again, we first find a pattern. So find the first 4 derivative. The first derivative is cos of 2x times the derivative of this angle. The derivative of 2x is just 2. So we just bring this 2 right here. The second derivative, the derivative of cos, it gives us negative. So it will be negative. This is 2 times the derivative of this angle will also be 2. So we'll bring this 2. So it's sine of 2x. So y prime prime prime, the derivative of sine is cos times the derivative of the angle. So this gives us 2 times 2. If you differentiate this angle, you get 2. So times 2. Sine of 2x. Oh, sorry, cos of 2x. We find the next derivative, fourth derivative now. The derivative of cos gave us sine. So it's minus, sorry, so the derivative of cos gave us negative sine, right? So it's negative times this, negative now is positive. So it's 2 times 2 times 2 times 2. Because when we differentiate this angle, we're going to get another 2. then sine of 2x. So this nth derivative now will just be 2 raised to some n. 2 raised to some n, right? So if we want to find the 98th derivative, the first thing we need to do is 4 goes into 98. What is the remainder if 4 goes into this 98? What will we be left with? So 4 goes into 9 2 times. 2 times 4 is 8, remainder 1, right? So 4 into 18, 4 times. 4 times 4 is 16, remainder 2. We're not concerned about this because this represents the number of times this had gone around the cycle. This is the number of times that we have differentiated this function and have come back to this original function. This is the number of times. So what we are left with now is 2. If we were to find, for instance, the 96th derivative, if we were to find the 96th derivative, because 96 divided by 4 is an even number, you will just have sine of 2x. Or not just an even number, but it is divisible by 4. Because if we say an even number and 10 is an even number, so 4 cannot go into 10 evenly. Okay, so now we're left with 2. So we must differentiate this sine of 2x 2 times. But this expression, this value, must always remain within this pattern. If we find in the fourth derivative, it is this coefficient raised to that fourth derivative. If we find in the 100th derivative, it must be that coefficient, which is 2 raised to the 100 power. So now, sine of 2x, we have to differentiate sine of 2x twice, right? So this is the second derivative of sine of 2x. So it means you must just multiply this by 2 raised to the power 100. So we're going to say minus 2 raised to the second power sine of 2x. So what will it be? We will have y raised to the power negative, let's say 100, or the 100th derivative. The bases are the same. We can add their powers. So this is 2 raised to the power 102 and sine of 2x. So now you can expand this 2 raised to the power 102. If this was 97, it means we would have differentiated this sine of 2x 1 time. It means we have to multiply this 2 cos of 2x by 2 raised to the power. Now this is now 100 now, right? It's 98 because we're differentiating this thing 98 times. So this is 98. So it's 98. So 98 and this 2 give us 100. So if this was 97, it means that this would have been 97, and then this expression in here would have been 2 cos of 2x. So it would have just been 98. So this is how we find the nth derivative of trigonometric functions. Very, very easy. If you want to find the nth derivative of sine or cosine function, is very, very easy. Just follow the pattern and you will find whatever derivative you are looking for. Thanks so much for watching. Please don't forget to subscribe, like the video, share, and see you in our next lesson. Thank you.